In this podcast, we will explore products distributed by Cotelec, a French leader in the component testing market. This podcast highlights the semiconductor test connectivity solutions from Smiths Interconnect, a company that offers advanced connectivity solutions for the aerospace and defense, medical, semiconductor testing, and industrial markets. It explains what an application-specific integrated circuit, ASIC, is, and discusses its different types, history, and design process. For any information, please contact Cotelec's engineers.
Welcome to another deep dive. Today, we're going to dive into the world of customized chips.
Okay.
Those tiny powerhouses you hear about ASICs.
Yeah.
And we've got some really interesting stuff to dig into today.
Right.
You've sent us excerpts from Wikipedia on ASICs themselves.
Okay.
A whole brochure from Smiths Interconnect about their semiconductor test solutions.
Interesting.
And even a little snippet about Smiths Interconnect's commitment to aerospace.
It's a fascinating area,
Yeah.
especially when you consider how ASICs have become so essential
Right.
to pretty much every piece of tech we use these days.
Yeah, it's kind of mind-blowing when you actually stop and think about it.
It is.
But before we get ahead of ourselves,
Right.
let's start with the basics.
Okay.
What exactly is an ASIC?
Yeah.
And why should we care about them?
An ASIC, it stands for Application-Specific Integrated Circuit,
Okay.
and it's basically a chip that's tailor-made for a very specific task.
Okay.
So imagine you've got a chip in your smartphone, all right?
Mm-hmm.
And let's say this chip.
Yeah.
It's specifically designed to handle the image processing for your camera.
All right.
It's not a jack-of-all-trades chip.
Yeah.
It's a master of one trade.
Okay.
It's crafted specifically for that purpose.
Oh, it's like a specialist.
Exactly. It's like
Yeah.
the difference between, a bespoke suit that's tailored just for you
Exactly.
and a ready-made one you grab off the rack.
Right.
Both might serve a purpose, right?
Yeah.
But the custom fit, that's where the magic happens.
That's where you get the performance.
Yeah.
I'm getting a sense of this specific part.
Okay.
But why go through the hassle of a custom design?
Well,
What's the advantage over a more general-purpose chip?
the advantage is efficiency and performance.
Oh.
Think about it. Those high-efficiency video codecs
Mm-hmm.
that let you stream hours of content without your phone dying,
Right.
or those digital voice recorders that capture crystal clear audio,
Right.
those tasks require a lot of processing power.
Oh, yeah.
And ASICs, they're designed to handle that load,
Okay.
but with minimal power consumption.
Interesting.
So they're significantly more efficient than their general purpose counterparts.
Okay, so it's all about...
It's like comparing a dedicated espresso machine to a regular coffee maker.
Right.
Both make coffee, but one is laser focused on delivering that perfect espresso experience.
Right. It's all about streamlining for that peak performance.
Exactly.
And, when you think about how much technology has advanced,
It's incredible.
we're carrying around essentially supercomputers in our pockets.
No.
How do they even design something so intricate?
It's pretty amazing.
The Wikipedia material made it sound pretty intense.
It is a complex process.
Yeah.
It starts with defining the chip's functionality, of course.
Right.
And this is where it gets really technical.
Okay.
They use something called hardware description languages,
Oh, wow.
which is kind of like writing code,
Right.
but for hardware.
Wow.
And then before they even think about making the actual chip,
Right.
they run simulations and verification to make absolutely sure that the design is flawless.
So it's not just about, sketching out a design on a piece of paper.
No.
It's like you're creating this incredibly detailed blueprint
Exactly.
for a microscopic city.
Yeah.
And then you have to make sure every single circuit, every connection
Every single detail.
is going to work perfectly
Absolutely.
before you even start building.
That's the key.
Wow.
And that's where this concept of standard cell design comes in.
Okay.
Think of it like building with Legos, but instead of just bricks,
Okay.
you have all these specialized pieces.
Okay.
Gears, sensors,
Yeah.
even tiny motors.
Wow.
And chip manufacturers,
Yeah.
they create these pre-designed blocks.
Okay.
Each one has a specific function.
It's like a library of little components.
It's like a library of building blocks.
Okay.
And designers, they take these standard cells
Yeah.
and they arrange them in unique ways
Okay.
to create the desired ASIC functionality.
So it's a blend of pre-designed
Yeah.
building blocks,
Yeah.
but then creative problem solving,
That-
put it all together.
It's a very collaborative process.
But I'm guessing it's not a one-size-fits-all situation.
You're right.
Wikipedia mentioned different types of ASIC design,
Yeah.
gate array, full custom structured.
Yeah, there are a few different approaches.
Is that about getting the right balance
It is.
of customization? And
Exactly.
you know?
You got it. It's about finding that sweet spot
Okay.
between how much customization you need,
Right.
how much performance you're aiming for, and how quickly you need that chip ready to go.
Time is always a factor.
Always.
Okay.
So you've got gate array,
Mhm.
which is the fastest
Okay.
and the most affordable.
Okay.
It's like adding frosting to a pre-baked cake, you know?
Right.
It's great for simpler designs,
Right.
but it offers limited customization.
Right.
Then on the other end of the spectrum, you've got full custom. This is like baking a cake from scratch.
Right.
You have complete control,
Right.
but it takes more time,
Yeah.
expertise.
All resources probably too.
Absolutely more resources.
Okay.
And then right in the middle,
Yeah.
you've got structured ASIC,
Right.
which offers kind of a balance.
A nice compromise
Exactly.
between cost, performance, and design time. So it's like choosing the right tool for the job.
That's a great way to put it.
Sometimes you just need a hammer.
Sometimes
you need a scalpel.
Exactly.
But no matter how you design it,
Right.
at the end of the day,
Yeah.
you need to make sure that tiny,
You.
incredibly intricate chip actually works as it should, right?
Absolutely. And that is where
Yeah.
things get even more interesting.
Okay.
Testing.
Yeah.
Testing is a critical phase in the development of any ASIC,
Right.
especially given how small and complex they've become.
And this is where I think the work of Smiths Interconnect comes in.
Yes.
Their brochure really dives into the world of semiconductor testing.
It's fascinating stuff.
And it gets into all these technical terms.
Yeah.
Test sockets,
Right.
probe cards,
Important stuff.
which, to be honest,
I understand.
sounded a bit intimidating at first.
It can seem that way.
Yeah.
Yeah.
A little bit like science fiction almost.
It does sound a bit like that, doesn't it?
Yeah.
But it's really quite fascinating when you get into it.
Okay.
Think about it. You have this incredibly complex chip with components so small you can barely even see them.
Yeah.
You need a way to interact with those components to
Right.
send signals in,
Okay.
get responses back,
Gotcha.
and make sure everything is functioning correctly.
Right.
That's where test sockets and probe cards come into play.
Okay.
They act as the crucial interface between
Right.
the chip
Right.
and the testing equipment.
Okay.
It's kind of
So they're like the intermediaries.
in a way, yes. They're like specialized tools
Right.
that a jeweler would use to examine a precious gem.
Oh, okay.
Yeah.
That makes a lot more sense.
It's a good analogy.
Yeah, I can visualize that.
Yeah.
But I can only imagine how challenging testing must be,
It is challenging.
especially with chips becoming more and more powerful,
Yes.
more miniaturized
Absolutely.
every year.
It's incredible.
It seems like it just keeps...
The pace of miniaturization is incredible.
We're talking about fitting millions,
Millions, even billions?
even billions of transistors on something the size of a fingernail.
It's mind-boggling.
How do you even test something like that?
Well, you're right. As
Yeah.
chips get smaller
Yeah.
and more complex, the challenges of testing them, they grow exponentially. And the Smiths Interconnect brochure actually touched on this. They were talking about
Yeah.
their solutions for different types of testing,
Right.
like area, array, peripheral, wafer level,
Okay.
and even something called package-on-package testing.
See, that's what I mean.
It gets complicated.
It's like every time I think I'm starting to grasp the complexities of this world,
Right.
a whole new layer gets peeled back.
It's true.
So could you maybe walk us through those different testing approaches?
Sure.
What
And-
makes them necessary?
Okay, so it's a bit like trying to assemble a puzzle,
Okay.
but the pieces are microscopic,
Right.
and you need these specialized tools even to hold them.
Oh, wow.
So take area array testing, for example.
Yeah.
Instead of those contact points being along the edges,
Yeah.
they're spread out across the entire chip surface.
Oh, wow.
Like a miniature city grid.
Okay.
It's a very common design,
Yeah.
especially for high-performance chips.
Yeah.
But it means you need a test socket that can make contact with hundreds, even thousands of tiny points
Oh, my son.
simultaneously. And of
Yeah.
course, without causing any damage.
Right. It's got to be really precise.
Precision is key.
And speaking of precise, what about that package-on-package testing?
Right.
I remember reading about chips being stacked on top of each other,
Yes.
almost like layers in a cake.
It's an incredible feat of engineering.
How do you even begin to test something like that?
Well, it's definitely a testament to how far miniaturization has come.
Yeah.
And you're right, it adds a whole other level of complexity to testing.
Yep.
You need to make sure Not only that each chip in the stack is functioning correctly,
Right.
but that the connection between them is absolutely flawless.
Wow.
And Smiths Interconnect has actually developed specific solutions for these kinds of challenges.
Okay.
They mentioned something called the Euclid test socket.
The Euclid?
Yeah, the Euclid.
Okay.
And it can apparently align and connect to both the upper and lower chips simultaneously.
Wow. It's like microscopic surgery.
It's pretty incredible.
So it seems like Smiths Interconnect is really at the forefront of this testing world.
They're definitely a leader in the field.
Yeah, constantly innovating to keep pace with
Absolutely.
how fast this technology is moving.
It's a constant evolution.
But I'm curious, their material also mentioned a commitment to aerospace.
Right.
That seems like kind of a leap from testing tiny chips in a lab.
It might seem that way at first,
Yeah.
but it really highlights how pervasive ASICs have become.
Okay.
We tend to think of them in our smartphones
Right.
and computers,
Or laptops, yeah.
but their reach extends far beyond consumer electronics.
Okay.
In aerospace, for example,
Yeah.
reliability and performance are absolutely critical.
Of course, yeah.
Think about the intricate systems in an aircraft.
Right.
Navigation and communication,
Yeah.
flight control.
Right. It's all got to work.
Those systems rely on
Yeah.
sophisticated electronics
Yeah.
that have to operate flawlessly
Right.
in some of the most demanding conditions imaginable.
So are you saying that
Yeah.
the same kind of custom design chips that power our smartphones are also used in aircraft?
The exact same principles.
That seems like a huge responsibility.
It is a huge responsibility, and it's
Overhead.
one that companies like Smiths Interconnect
Yeah.
take very seriously.
Huh?
Remember that snippet about their solutions for flight-critical systems and
Yes.
challenging environments?
Yeah.
That speaks volumes about the level of robustness
Okay.
and reliability their technology offers.
All right.
They're not just testing these chips.
Mm.
They're ensuring they can withstand extreme temperatures,
Right.
vibrations, and the unforgiving demands of high altitude.
Wow.
Yeah.
It really puts into perspective the importance of what might seem like a very niche area of
It's
technology.
easy to overlook.
It's not just about faster smartphones or whatever.
Yeah.
It's about ensuring that critical systems function reliably
Exactly.
when lives are on the line.
Absolutely. The stakes are very high.
Yeah.
And that brings us to a bigger question, I think.
Okay.
We've talked about what ASICs are,
Right.
how they're designed, and the intricate process of testing them.
Right.
But if we kind of zoom out for a second,
Yeah.
what does it all mean?
Right.
What's the significance of this technology in the grand scheme of things?
That's the million-dollar question, isn't it?
It is a big one.
What I'm gathering from all of this is that
Yeah.
ASICs kind of represent a shift
Okay.
towards hyper-specialization in electronics.
I think that's a good way to put it.
Instead of this one-size-fits-all approach,
Right.
we can now tailor silicon
Exactly.
to meet these very specific needs,
It's about customization and optimization.
which in turn
Yeah.
opens up a whole new world of possibilities.
Precisely.
Like we're not just limited by,
It's not just about
Yeah.
making things smaller and faster anymore.
Yeah.
It's about making things that are specifically designed
Right.
to do exactly what we need them to do.
wow,
And that's really powerful.
it is.
Think about the potential in
Yeah.
fields like medicine.
Okay.
ASICs could power next-generation imaging devices
Okay.
for earlier disease detection.
Wow, that'll be huge.
Or they could enable
Yeah.
highly personalized drug delivery systems
Oh, wow.
tailored to an individual's genetic makeup.
It's mind-blowing to think about the possibilities.
It really is.
And it's not just medicine.
No, not at all.
It's it.
This technology has the potential to impact almost every aspect of our lives.
Like what else? What are we talking?
Renewable energy,
Okay.
environmental monitoring,
Mhm.
advanced manufacturing,
Right.
artificial intelligence.
Of course.
The list goes on and on.
Oh.
As we demand more from our electronics,
Yeah.
ASICs will play an increasingly vital role
Right.
in making those advancements possible.
It's really pushing the boundaries of what we thought was possible.
It really is.
It's almost like we're on the verge of this whole new technological era,
I think we are.
one where the only limit is our own imagination.
And our ability to design and test these chips.
Right.
Because it's one thing to imagine it,
Yeah.
but it's another thing to actually make it work.
To bring it to life. But with great power comes great responsibility.
Yeah. That's always the case with any new technology.
I imagine the ethical considerations surrounding this kind of technology.
Oh, absolutely, are pretty complex.
They are complex, and they're conversations that we need to be having
Sure.
as this technology continues to advance.
Yeah, those conversations are already starting to happen.
They are, and they're going to become increasingly important as we move forward.
So sure.
But for now, maybe we can shift gears a bit and dive into some of the specifics of Smiths Interconnect's testing solutions.
Okay, let's do it.
They provided some really interesting details about their Da Vinci series, which is designed specifically for area array testing.
Yes. That's the one that sounded like... Yeah.
It was straight out of a science fiction novel.
It is pretty impressive technology.
Let's hear more about it. So remind me again, what makes this Da Vinci series so special? It's just a socket, right?
Right.
How complicated can it be?
Well, it sounds deceptively simple.
But
you have to remember, we're dealing with components here that are often smaller than the width of a human hair.
Oh, wow.
So even the simplest things become engineering marvels at that scale. And what makes the Da Vinci sockets really stand out is their use of something called insulated metal.
Insulated metal?
Yeah.
That sounds like a contradiction in terms.
It does, doesn't it?
Yeah.
But essentially, they've found a way to create these conductive pathways that are also incredibly well insulated.
Wow.
And this is crucial for a couple of reasons. First, it minimizes signal loss. And second, it helps prevent something called crosstalk.
Crosstalk?
Yeah, have you heard of that?
I'm not sure.
It's basically interference between signals.
Oh.
Think of it like this. You've got thousands of tiny wires packed incredibly close together. Without proper insulation, the signals would get all jumbled up.
Oh, right. Okay.
And that would lead to inaccurate test results.
So it's all about keeping those signals clean and clear.
Clean and clear.
Even at the microscopic level.
Even at the microscopic level.
Wow.
It's pretty remarkable.
It is.
When you think about it.
Yeah.
Yeah.
But going back to the brochure, they also mentioned something about the Da Vinci sockets being incredibly durable.
Yes. Durability is key. Because these sockets aren't just used once and then discarded. They're put to work in these high-volume manufacturing environments where they might go through thousands upon thousands of test cycles.
Wow. So they have to be.
They have to be incredibly robust.
Yeah.
Imagine plugging and unplugging your phone charger thousands of times.
Yeah.
You'd want a connector
that
can withstand that kind of wear and tear.
Yeah, for sure.
It's the same concept here, just on a much smaller and much more precise scale.
They really are the unsung heroes of the tech world, aren't they?
I think that's a good way to put it.
Yeah, quietly ensuring that.
Behind the scenes, making sure everything works.
All those billions of chips being produced actually work as intended.
It's a critical role.
Yeah.
And it's only going to become more demanding as chip technology continues its relentless march forward.
It seems like it's never going to slow down.
It doesn't seem like it.
Yeah.
We've talked about shrinking feature sizes, increasing complexity.
Yeah, it just gets more and more complex.
It puts immense pressure on the testing side of things.
Right, to keep pace.
Exactly.
It's like a constant game of cat and mouse.
It really is, with testing technology always trying to catch up.
Yeah, always trying to stay one step ahead.
One step ahead.
Well, it's been fascinating to get this glimpse.
It's a fascinating field.
Into the world of ASICs.
It really is.
From their design, their diverse applications, to the intricate art of testing them.
It's amazing how much goes into it.
It really is.
When you really start to dig in.
Any final thoughts before we wrap up our deep dive?
I think the key takeaway here is that even the most groundbreaking technology relies on a foundation of precision, rigor, and a whole lot of behind-the-scenes work.
Yeah, a lot of people we never hear about.
Exactly.
Doing really important jobs.
The unsung hero.
The unsung heroes.
That's right.
Yeah, I like that.
So the next time you pick up your smartphone or interact with any piece of advanced electronics, just take a moment to appreciate
the incredible dance of technology that's happening at a microscopic level.
It's pretty amazing.
To make it all possible.
That's a great point to end on.
It's been a pleasure chatting with you.
Thanks for joining me on this deep dive into the world of ASICs.
Anytime.
And to our listeners, we hope you've enjoyed this journey.
Thanks for listening.
Into the heart of modern technology. Until next time.
See you next time.
Keep exploring, keep asking questions.
Absolutely.
And keep diving deep.
Keep diving deep.
Into the world around you.
In this podcast, we will explore products distributed by Cotelec, a French leader in the component testing market. This podcast highlights the semiconductor test connectivity solutions from Smiths Interconnect, a company that offers advanced connectivity solutions for the aerospace and defense, medical, semiconductor testing, and industrial markets. It explains what an application-specific integrated circuit, ASIC, is and discusses its different types, history, and design process. For any information, please contact Cotelec's engineers.